1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3. 1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3. 1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3.
1, 2, Web 3. 1, 2, Web 3.
Greetings, developers, metaverse architects, and hackathon participants. Welcome back to another 1-2 Web3 workshop. I'm Phil, head of events for Moralis, and I'm here today with Dan of Tableland. He works with Dev Relations, and today he's going to be talking to us about using the latest tools to deploy NFTs on Polygon using Tableland. He's going to go over exactly what Tableland is, how we use it with our dApps, and of course, how we qualify for important prize money in developing our dApps during this event. Welcome to the stage, Dan.
Hey, how's it going? Happy to be here.
Well, we're glad to have you. And I understand that you have some slides to share with us. If you want to share your screen, I can pop those up there for everyone.
Sounds good. Let's do that. Cool.
All right.
How are we looking?
There we are. We can see your screen.
Cool. So I'll go ahead and get started. So yeah, let's kick it off with just like what is Tableland, and then we'll go into an actual sort of tutorial. And I have some resources that I'll share throughout this just to make it easy for people to follow along, because there's lots to unpack with what I'm going to be walking through. But first off, what is Tableland? So you can sort of think of Tableland as a decentralized database network focusing on sort of the relational data model. So basically, there's a network of validators, these nodes that are running SQLite and sharing that state between them. But all of the on-chain rules and access control is managed on the chain itself. So think of Tableland as this sort of network that is managing this database, but also in order to interact with it, you need an on-chain component. So in this tutorial that we're walking through today, we're going to be using Polygon, but Tableland is multi-chain, cross-chain deployable. So we have contracts on Ethereum, on Optimism, on Arbitrum. So it gets pretty cool when you think about just composability in general and how you can use Tableland to really bridge the gap between these different chains. So essentially, the gist of it is you can think of Tableland really allows any blockchain to be turned into an application database because of that sort of decomposing a database into two components. So those on-chain rules that dictate who can write to a table or update, insert information, update information, delete information. You can use smart contracts to actually manage the access control rules and everything. So an example of that is maybe you, and we won't be doing this in the tutorial, but just to sort of shed light on what you can do with Tableland, you can set up ACLs that would say something like only this user, this address with a certain balance and an owner of this token can update a table state in the Tableland network. So there's this, again, on-chain and Tableland network sort of components that are all dependent on that blockchain, and really enable some cool things that anyone can do with NFTs or really anything from just general application data perspective too. So as noted, we have this network of Tableland nodes that are running SQLite under the hood. And then on top of that, we're really in parallel, I guess. You can see those smart contracts as like a way for these validators to know what's happening. So the Tableland smart contracts allow you to do things like creating a table or writing to a table. So if someone calls a Tableland smart contract, they can create that table. They can enable those ACLs to dictate who can access the table itself and write to it. And we call that our registry smart contract. But then on top of that, we also have different clients such as a JavaScript/TypeScript SDK and a CLI tool. So depending on what type of developer you are, you can use Tableland. So it doesn't really matter, I guess is what I'm trying to say there. So if you have some, let's say, React app or some Svelte app, something on the front end, you can use Tableland and our JavaScript SDK. Or if you're more on the Solidity side of things, you can strictly just write contracts and call the contract directly. So pretty cool in terms of those opportunities. And maybe just to paint that picture a little bit better. So every time you create a table on Tableland, it's actually minted as an ERC 721 token. And if you go onto OpenSea and search Tableland tables, you'll find exactly what they look like. And this is a representation of like the NFT itself. So it's more of NFT as that like data primitive. It's not a collectible necessarily, because there's an infinite number of tables that can be created. It's really just a utility established with it. But because it's an NFT, we also do have this sort of dynamically rendered SVG based on the information itself. So if you check out OpenSea, you can see what the tables look like. This example is the name of a table. It's a rigs holder snapshot. This one was minted on Ethereum mainnet. It has this number of rows, this number of these specific columns with their schema. And in the tutorial, we'll walk through what that looks like and how this is actually materialized as a whole. Cool. So let's talk about what we'll be walking through here today. So it's going to be a pretty simple NFT, rather static metadata, but note that Tableland really enables dynamic metadata, mutable metadata to happen based on the permissions that are set when you write to a table. So when we get into some of those details, you can really imagine the possibilities where if you want, let's say, an attribute to change based on user input or user feedback, maybe it's some even type of off-chain interaction that you could imagine how to architect this. It could be something like Chainlink that is pulling off-chain data and writing to a table, or just like on-chain interactions that are also updating the table state. But that allows the NFT to potentially be dynamic and truly mutable in nature. This one is more of just a standard NFT that's static. So really it's up to the developer in terms of how they want to architect things. But what it will look like is on the right-hand side. So we have, if you search, I think it's called 2tables NFT, one word, on OpenSea testnet, you can see what this actual output will look like. And then the bottom right-hand corner is really what Tableland is doing. So you can see that NFT metadata, it's composed actually across 2 tables that have been deployed on Tableland. So if you're familiar with relational data and how that all works, basically using SQL, you can compose things together with a simple just select all type statement or select these specific columns and fields type statement that composes it into an ERC 721 compliant metadata schema. Cool. So in particular, we will be creating a smart contract, just standard ERC 721. Some intricacies with that include a base URI that will be pointing to a Tableland gateway URL. So again, think about, just take a step back. We have the base chain where all of the instructions are being emitted from a smart contract. So this tells the Tableland network what to do. And then that Tableland network of validators are listening to those events and materializing the actual SQL statements. And then in order to access that network, we have a gateway built on top of the Tableland network. So when you look at things like OpenSea or just querying that gateway in general, we'll show you exactly what that looks like. You can just access that gateway itself. And in the smart contract, that's actually what's being referenced. So it's this base URI, token URI type setup with a query embedded that composes those tables together to create that ERC 721 metadata schema compliant JSON. So there is some usage of both NFT.storage and Polygon in this as well. So NFT.storage is a great tool for pinning files to IPFS. So through this, we'll actually have some local images that we're going to take, pin them to to IPFS using NFT.storage, and then we'll take some also locally hosted just JSON files, read them, sort of merge the data together. So now you have this URL that's pointing to NFT.storage and like where this image is hosted, and you have this JSON data, because a lot of people are more familiar with metadata being JSON. So we're going to take all that, read it, sort of like reading the file itself, and then write it to tables instead. So when people think about like NFT metadata, often they'll deploy files to IPFS, which is a great solution. And we're actually obviously using IPFS for the image itself, but just to enable some composability and queryability, that's really why we're trying to put things in tables and make them dynamic and queryable in nature. And lastly, we'll be using Hardhat to really deploy all of this. Now, if you are following along, here are some of the different resources that may be helpful. docs.tableland.xyz. We have a blog site, dev.tableland.xyz. And then, as noted, some of the different ways you can interact with our network and some helpful resources there. And then last thing before we get started is just note that we have sort of this pilot program, which is a way for developers to, even outside of just this hackathon, get some additional grants and funding for the things that they're building. So check it out, tableland.xyz/pilot program if you would like to apply. Alrighty, let's dive into things. And just to confirm, can you see that my screen switched to a new view?
Yes. Yep. We can
Okay,
see
cool.
your top bar as well.
Okay, cool. So yeah, this was the pilot program. Just thought I'd shout that out real quick. And note that we are basing a lot of this tutorial using the logic that we actually deployed with our Tableland rigs. So if you're not familiar with Tableland rigs, it's actually a real NFT collection. It was top 5 in OpenSea back when we launched it, and it was really just sort of dog fooding Tableland. So we're trying to figure out how to enable some cool experiences with NFTs, and instead of just building some tutorial, we actually just deployed an NFT instead. So exploring the rigs tables, this is pretty interesting if you want to go down the rabbit hole in terms of exactly like how everything is architected. And in addition to that, we've actually open sourced the tooling that we use for rigs. So if you want to even go ahead and check it out yourself, you can use really the exact same logic that we used, or at least similar to it, for deploying an NFT. Again, different from what we're doing here today, but at least a little bit of helpful context for what we will be building. Alrighty, so one thing that might be helpful is check out Tableland network /tutorial-2tables, well, tutorial 2tables NFT Polygon. This is where everything is hosted. So the deployed app, all of the logic that I'll be walking through today. And it's also a write-up on our doc site. So check it out over here on the left-hand side. You'll see tutorials, build, where does it go? It's not showing up there, but deploying an NFT on Polygon, you can see what that looks like in the bar up top. A couple more things just before we get started. I know there's a lot of things to stay up here in the beginning, but we, as noted, are live on different networks. So if you're interested in just checking out anything else, you can view this deployed contract section of our docs. We'll be using Polygon Mumbai, and then you can see exactly and interact with the contract if you want to just take sort of that approach. And then lastly, this is exactly what the end result will be. So we have this 2tables NFT that we'll be deploying. There's only one that exists in this collection. but we'll have this, basically this image hosted locally in just some directory that I have on my computer. And in addition to that, we'll have that JSON file, merge them together. What's cool is that this is all just composed using Tableland. So if we look at some of the properties, the attributes, all the details, this is really just a query on that gateway URL that I talked about earlier. And I'll pull that up right here. So if you look at the metadata itself, it looks like everything you would expect with an ERC 721 token. But what's cool is up here at the top, you'll notice this gateway, testnet.tableland.network, query, mode list, and then a SQL statement. So the way in which this is all actually created, we have two tables. We're going to call one main and then another one attributes. And then we're going to use this SQL statement, select JSON object, ID, name, etc., to then bridge these two tables together and create this actual metadata on the fly, essentially. And when I talked about dynamic NFTs, immutable NFTs, like this is where things get interesting, because this query URL, this select JSON object and everything, that is in the smart contract. So you can get creative in terms of how you even deploy an NFT and its token URI. So you could have an NFT that maybe changes the token URI to use a different parameter. So instead of maybe trait type, role is admin, maybe it's just you change it later at some point and the value is user instead. So cool things that you can build with that. Alrighty, let's just take one more look at how everything is architected, and this maybe can help just paint the picture of exactly how this data is married together. So if we look at sort of the project setup on the right-hand side, you can see that we have a number of different directories and files. So just going top to bottom, you'll see contracts. We have a two tables NFT. This is just the standard ERC 721 token, where we have some of that information pointing to the Tableland network. We have images, we have metadata JSON files, we have some scripts, and then some test suites as well. In terms of the end result, this is exactly what I'm talking about when I say, hey, let's have a main table and let's have an attributes table. And it's actually like an efficiency gain when you think about it, because instead of just having, let's say, a static JSON file where there's a lot of data that is sort of redundant between them, they're the same essentially. So some of that like top level data, like description maybe, is going to be the same, but you can use SQL to compose things together. So then you can have sort of like a really just efficient setup where you have like a main table that has every single NFT that was ever minted. So you have your unique token ID 0 through, let's say, 10,000 if it's a 10,000 NFT collection in total. But instead of just having a bunch of redundant traits and whatnot, you actually have like this separate table, like the one I have here, which I'm calling attributes. And that's sort of just listing exactly what those attributes are. And then you can, again, use SQL to compose everything together. Cool. So as far as some of the initial setup, we will be using, and if you want, you can even change the images and metadata that you have locally here on in this directory. So the most important thing is probably, just make sure that you pull down these and even swap them out for your own unique images if you would like. We're going to have a .env file just to set up some environment variables, and then just an additional couple of steps. Set up an NFT.storage account. Set up here. We're going to be using Alchemy, but it obviously could be any provider out there. And then some additional things at the end, such as setting up like a Polygon scan API key just to make it easy to actually like verify the contract and things like that at the end. So basically what you're gonna have is a .env file that looks something like this. And if we scroll back over into NFT.storage, so check that out here. Up here at the top, API keys is where you'll pull that down actually. And I have a number of files that I've uploaded through this process. And basically when we actually like write the code, it's gonna automatically upload this information. But obviously, if you'd like, you can just do it sort of manually. I just prefer to program things instead. So yeah, let's get started. So here on the right-hand side, we have those images directory and the metadata directory. The metadata is basically going to look like this. So we have these different attributes that of the metadata itself, or different keys of the metadata itself, that instead of just like deploying maybe a JSON file to some network, we're going to take these different fields, name, description, image, attributes, and instead basically write them to a table. So these will be our table headers. So we're going to have a name, description, image, attributes, table header, or one will have these three in particular, and then a second one will have these as the actual column headers as well. So it's very structured data, it's very predictable, and that's really why Tableland thinks this is just a different way to approach metadata as a whole, because when something is really structured, it is predictable, it's really just meant for a relational data model, rather than trying to, fit a, what's the term? Circle into a square hole, or inverse, vice versa. I can't quite remember, but here is the example of the image. You saw that on the OpenSea page that I was just reviewing. And this is actually the Tableland rig, just an image I pulled down from that collection. There's a lot of cool ones out there. And if you are an NFT collector, or even like quick plug is that Tableland is looking at our Tableland rigs as a way to really like flip the script and add value to being a developer. So it's really a developer first NFT. So if you're interested in more, hop in our Discord. Alrighty. So here we're gonna just do some basic imports up at the top. So this is a hard hat project. In order to get set up, you can just do the standard MPX hard hat. I think that's the initial setup, and just go through like the really like introductory steps. That's all listed on the tutorial if you're curious exactly what steps to take in order to get through some of this initial setup. But we're going to do a few different things. So we're going to import this script that we're going to write later, prepare SQL. We're going to import the Tableland SDK and some additional things, just because I have some node issues on my computer, so I have to use an older version that leads to some issues. But not everyone necessarily has to do this. It just depends on how you set up everything. But in this scenario, I'm using Clojure.js, so kind of required there. But anyway, so a hard hat tutorial really comes with like a standard sort of setup. You have this main function, and then down here at the bottom, when you run the npx hard hat scripts, whatnot, we'll walk through that at the end, but it will run this function. And basically what we're doing in the beginning is just some initial setup work with Tableland. So like probably the main thing to understand is that whenever interacting with the Tableland network, at least through the SDK, the first thing we're going to want to do is connect. So that connection is basically establishing a connection with the base chain that we're going to be interacting with, because anytime you create or write to a table, it must flow through a chain first. So an on-chain interaction dictates that sort of off-chain materialized SQL state. So on-chain interaction emits instructions, our network of validators listens to it, and then materializes the actual statement that's happening there. When we talk about those different tables, we have one that we're calling main and one that we're calling attributes. And I mean, there's what's great about SQL is that if you don't come from like a strong SQL or relational database sort of background, it's pretty easy to get started and learn. There's a million resources on SQL. It's been around for, I think, since the 70s. So yeah, there's just a lot, at least from that learning curve aspect. You can even learn outside of Tableland and then come to the Tableland network. And we're still working on a lot just from a docs perspective, fair criticism that we've heard. So yeah, just a point to keep in mind. There's a lot going on there around SQL, but bridging SQL into the Web3 world just to make things easier, because it's been around for so long and it's battle tested, and there's a lot that you can just leverage from those past learnings. But anyway, so the way that we see this is, okay, the first thing that you do is you connect to the network, to the Tableland network. Next thing you do is create some tables, and every table is going to have some sort of schema associated with it. So this one we're saying ID integer, we're going to say it is the primary key, so it's unique to that table. We're going to say that one of the columns is called name, it has of type text. Similarly for description, it's a type text, and then image as well, type text. And I noted this in the slides sort of in the beginning, but Tableland has a specific SQL specification. So it's sort of a flavor of SQLite, just some constraints or some reduction in terms of the features as we sort of kicked off this network, maybe around 9 months ago, is incepted a little bit over that. So we've been building ever since then. And we're going to continue to add features over time, but it's really a subset of things for now as we figure out what developers need and want, and really what makes sense from more of that decentralized aspect, because there are limitations if you just compare it to a strictly SQLite database. But generally, most of the features are available. So creating tables, inserting into them, writing to them, deleting values from them, and even sharing ownership to allow others to collaborate on your table. So you can have, from like a use case perspective, we're talking about NFTs here today, but you can have different types of setups where maybe a table isn't just NFT metadata, but it's a knowledge base where only certain users can write to that table itself, and then that's rendered using that gateway at some application layer level. It could be things like gaming, holding like game state or leaderboards, things like that. But NFTs, again, great use case there. So we have our main table, we have our attributes table, and as we showed in that JSON metadata, we are basically going to try to link that table like to the main table schema. So we have our main ID, we have our trait type, and then we have our value. So the trait type in the example over here was like the type of the fleet, as well as some random attribute that I came up with, which was just role. So we're saying that these are going to be basically each a row in the actual table itself. So fleet, foils, role, admin. Cool. So connect, let's just define our schema up front. And then we are also going to define what we call a table prefix. So if you check out any table on Tableland, it sort of comes in this format: prefix, chain ID, table ID. So prefix is some sort of human readable name. Here we're saying our prefix is table NFT main, table NFT attributes. Chain ID is going to be, in this scenario, we're deploying to Polygon, so 80,001. If you're deploying to, let's say, Ethereum, the chain ID would be 1. And then table ID is really just a token ID, standard with, if you're minting any ERC token, it's going to have a unique identifier for the token itself. So these three combined actually like make this one table unique across any chain. So as I noted, we're deployed on Ethereum, Polygon, Optimism, Arbitrum, et cetera. And we're going to continue to add features and add additional networks over time. But knowing this, with this prefix chain ID, table ID, that means that everything is unique across at any single chain. So you can guarantee that a table name, which is that three sort of subsets, that table name is unique in its entirety. So you can have like cross-chain composability experiences when you're reading from maybe like Ethereum mainnet. You could have like an NFT deployed on Ethereum mainnet that is reading metadata from a table deployed on Polygon, let's say. And that is a design decision because Polygon is a lot more inexpensive than writing to something on Ethereum. So when I talk about composability, even think about it from that cross-chain perspective. And just sort of moving down the list. So now we connected, we defined our schema, some of the other setup work around the table name. Then we're going to create the table itself. So here we're establishing Tableland create We have that main schema. We're defining what that prefix is, which is technically optional. You don't have to define a prefix, but it can be helpful, especially when just setting things up and trying to understand which table is which. And what this returns is the actual table name and the transaction hash that the table is minted at. So every table is an NFT, so it comes with that on-chain interaction, that transaction hash, when it is assuming everything is valid. And that's what I'll walk through in that next step. But assuming everything is valid, it's good to go. You'll have these values returned. So like one point is that when interacting, you want to make sure that the table was successfully created. So we have this helpful receipt method just to say, hey, what happened with this transaction? Was it successful? And do some validation there. We're going to do the same for the attributes table. So that first step was for the main table. Now we're going to do attributes table, make sure everything is good to go. And then at this point, we have created a couple of tables, all just using the SDK, no contracts, no additional helpers quite yet. The next step is actually diving into like preparing the SQL. And this is where we get into reading data locally. This is where we get into using like nft.storage to pin files to IPFS and create like the insert statements for the table's metadata. And we're going to skip over that real quick and then just jump down to the smart contract, which I think might be a little bit easier just to kick things off and understand exactly how things are architected there. So first thing to note is that we have this base URI. So if you're familiar with any NFT, and here I have one set up for basically importing just the Open Zeppelin standard for an ERC 721 token, and then a helper library with strings. But we scroll down and we're going to be setting this base URI string, which is a storage variable in the contract. And what this allows us to do is have that access to the Tableland gateway. So when we look at that OpenSea interaction, when we're reading the token URI of some minted token, it's really looking at this ERC 721, we're looking at the base URI string, which is pointing to that Tableland network. And this is really what it looks like. And when I showed that a minute ago when we looked in the browser itself, but this is pointing to that gateway on top of the Tableland network. So testnet Tableland network, query mode list, and then the string itself, which is that select all or select whatever statement from the tables. And then the rest of this is just, sort of boilerplate rather type of deploying type of steps that Hard Hat comes with, or technically Ethers because it's being used under the hood there. But so just want to make that point in terms of exactly how things are being deployed using this base URI, and then some additional interactions that we'll see here shortly. Cool. So let's take a look at the actual two tables NFT. We mentioned that there is a base URI string. We also just walk through what the different table names are. So if we scroll back up to the top there, we had defined our table names, our main name, our attributes name, and these are actually later used when we're deploying the table itself, the ERC 721 token. So we're going to be setting these in the constructor method. So main table attributes table is coming from that Hard Hat script. Cool. And then a couple other of the storage variables up the top. We have a token ID counter just to maintain that unique ID associated with any NFT that we're minting. And then in this scenario, just to have a limit on things, you can see that I only have 2 images, 2 metadata files. So the actual number of tokens minted is just capped at 2 in total. These are just some standard type of methods that come with an ERC 721 token. So we're setting that base, or at least like allowing that base URI to be accessed via our token URI method. We have this total supply just to really explicitly state, at least from, I think here I made it public just to make it easy for people to see how many are in total. And then where it gets a little bit cool and gets into the Tableland aspect. So here we have our token URI, and that is, when I call this is the token URI specifically for a single token. So when you call the token URI method, that's what OpenSea and everything is using under the hood to display metadata, and then it's coming up with this using that Tableland gateway query. And so you'll notice this is sort of like the end state of what we're going to come up with. It's this select statement JSON object. We're basically looking at the table and using SQL functions, SQL sort of helper functions. JSON object basically constructs a JSON object, and then we have JSON group array with a nested JSON object. So it's reading data from these tables and basically moving it into the way that you want it to be displayed within the token URI itself. So that's exactly what this is doing: ID, name, description, image, attributes, and then composing that together via the query. So we're going to select this data from these tables, from main table, attributes table that we set in that constructor method. We're going to basically make sure that there's a matching ID between the two, and then we're going to group them together by that ID, which enables this metadata to only be for that one token. Part of this, at least in this example, I took this query and basically just used some URL encoder. There's a lot of tools online that you can use if you want to do it offline, or there's definitely libraries to encode some string with the proper URL encoding. But you can see, like in this example, select %20, any URL is going to have that as a space. So select %20, that means space, JSON object, and then so on and so forth. So we're going to basically form that query, past that main table, past the attributes table, just based on everything that's mirrored up here in the query above. We're just recreating that here in the actual query string. So then when token URI actually returns, it's giving you that string of the entire URI itself. So the base URI plus everything in this section in particular. And then lastly, we're going to mint a token because we're obviously minting NFTs here. So this is just sort of standard thing. We're going to safe mint, we're going to increment the counter, and then that ensures that every token ID is unique. And note that because this is sort of a workshop, this is a tutorial, it's maybe not the best practices for everything in terms of visibility on the different state variables and whatnot, but just something to keep in mind. At least makes it easier for accessing everything. Alrighty. So this is where we get into some of the weeds of everything and actually like parsing files and reading files. And this is where we use, and all this is using Node.js and Node under the background, under the hood. But nft.storage is again where we will be uploading the images to, and at least like using them to push it to IPFS and pin it there accordingly. So up at the top, we have some helpers. We're going to read files from a path. We're going to upload that image using nft.storage here based on some of those environment variables that we set up in the beginning around just the actual API key for interacting with nft.storage. And then we're going to parse a metadata file, and then we're going to basically build everything together. So this last function, prepare metadata, is going to be using everything up at the top and just brings it all together to make it really some compact type of method. So prepare metadata, just to go up, and we'll walk through this real briefly, just because there's some actual file parsing that probably more helpful just to read offline through that tutorial. But as noted, so we're going to be reading a file from a path. We're going to be uploading that image to IPFS, and this is really just as I noted, the key thing to remember here. So using just how I've named the files themselves, we're going to say ID 0.jpg is the file that we're reading, and the metadata and the images are basically aligned based on that prefix, the file name. Ignore the actual file extension, but 0 matches with 0, 1 matches 1. Pretty straightforward there. So great, we upload the image. What this returns is the actual CID associated with that image on IPFS. And then the next step is actually looking at this metadata, and you'll notice that the image is empty. So in this tutorial, we'll just, because it's kind of cool, we'll actually write to this file so we can see what that gateway URL looks like to the nft.storage hosted. I can't actually quite remember exactly what that looks like, but we'll see it at the end. Oh, here we go. nft.storage link. So we'll have that image CID from the step above. It's going to be included in this string templating with the NFT storage link. And then we're going to write that data to our JSON file. And then we're just doing that for fun. But really what we're doing is building an object. And then we're going to parse that object later into SQL statements. So that's essentially what parse metadata file does that upload process. It reads the file. It merges the actual keys and values together and builds this actual metadata object. And then this sort of handles some additional steps just to make sure it's a solid output. Again, it's sort of merging everything together in those functions above. So metadata processing, and just to even, let's take a step back. So what have we done so far? We set up our project. We walked through the deploy to table script. That was the first thing we walked through. And that was like showing you how to use Tableland, some initial setup with schema and table names, and just an overview of the end deployment that we'll also hop back into. We just touched on metadata processing, which is reading from these couple of directories and then building the actual objects that we're going to use in this next step, which is preparing the SQL. And really all this does is, in those steps that we walked through at the beginning, we had created those tables, and well, now we need data in the tables. So prepare SQL for two tables is preparing SQL for those two tables. And basically we're going to create these different statements within this file in particular. So insert into, we have our main table that's going to be passed to this function when we actually run that final deploy to table script. So insert into main table, ID, name, description, image, values, and then here are the values. So quick primer on SQL. Based on like how you're defining that schema, you're going to have ID ints. These we said were all text, and that's why they look as such. So ID ints is just straightforward. You just pass it as an ID as the number itself. And then anytime you see text, always make sure to enclose some sort of text. That string in single quotes it's an SQL thing. So just a best practice there you should be aware of. So make sure everything is always enclosed in those single quotes. So for each main table, so each NFT that is minted, we're going to have more than one attribute, right? So that's the rationale for this next step, where I have sort of a loop going in terms of reading the data. So we have this top level information. Every NFT has this. And then we have this information down below where there are multiple attributes per NFT. So boom, main table statement, insert into, similar type of pattern, just with different data for the attribute statement. And this will build multiple insert statements into that in its entirety. So insert into, we have that main ID, which links to the token ID, that unique identifier for the token, trait type values, and then the values themselves. So once that happens, you can see insert SQL statements. That was defined up here at the top. So we're really just building an array of these different SQL statements. And when we deploy the script, it's going to be running or reading from this array. And I'll look at, oh, here's the main insert statement. We're going to insert that first. And then we're going to look at each individual insert statement for the attributes. And note, there's ways you can be way more efficient with this, just with how you design the SQL and how you really map everything else out here. So like efficiency is something to consider, because every time you create or write to a table, it is an on-chain interaction. And anytime you interact with the contract, you're paying transaction costs for that. So optimization around like queries is a pretty interesting point. So even things like, if you look at how I've defined these different columns, you're paying for every character essentially, because whatever you pass to a smart contract function, that actually has to read that function. Even though it's being emitted, the SQL statement is emitted as like a cheap event. That's where all the SQL instructions come from. Every character that you use is going to count. So like if you want to get into query optimization, you can maybe name things like this, so that later when you're actually, let's say you have a high throughput application and you're writing a lot of tables quite frequently and updating, mutating that data, even like in an NFT metadata scenario, if you want to have a dynamic NFT and it's constantly updating information, it might be helpful just to think about, okay, how do I minimize and optimize this query for the lowest number of characters possible? There's a lot that we're doing to work on that a little bit more, but thought I'd share that tidbit. Alrighty, so process the metadata, we prepared the SQL, and then we're gonna actually go through that deployment process. So recall, we did all that setup, connect to the Tableland network, looks at that chain that we're deploying to Polygon Mumbai. We're gonna we set up the actual schema, we set up the prefixes, the different create actual transactions. So we created those tables, which is an on-chain interaction. We did some validation with receipt, which is just a helper method if you are using SDK. And then here's where we finally marry everything together. So we have the prepare SQL for two tables method here, and that returns that array of different SQL statements for the inserts into the table. And then what this script does right here is reads each and every one of those statements. And based on how things were designed within that actual file, we're looking at the NFT's main and attributes, objects or fields within that actual object that is built in the prepare SQL for two tables statement or function. And then here we're going to be iterating through them. So we're going to call Tableland.write. And really all that happens here is that you are passing an insert statement into the write method. So there are a number of methods that Tableland has, but as noted, like probably the most important ones to understand are connect. You always need to connect. Create, if you want to interact and create a table, you need to create the table. If you want to insert into it, we have this method called write. Receipt is that helper, just helpful for at least any sort of like, just ensuring the transaction actually went through and making sure everything is good there. We do have some other helpers that are more geared towards like validating things, and even like a separate SQL parser that you can check out on our GitHub, just to validate the validity of a SQL statement, so you're not just writing erroneous statements that don't actually materialize. And then one that we won't really have here, but we also have Tableland.read. So if you want to read from that gateway within, let's say, a front end apt, React, whatever, you can call Tableland.read and then like a SQL query. So like select all from whatever, and that'll give you an object back, and you can render that in some sort of user interface. So we're writing to the table, the main table up here. We're going to be writing to the attributes table down here. And then we get into some of that stuff we walked through at the beginning, which is actually deploying the table itself. So as I talk through this, let's just run the script. And if you're familiar with Hardhat, it's pretty straightforward. So npx hardhat run scripts for deploying the two tables, and we're specifying the network as Polygon Mumbai. So throughout the code, you'll probably notice that there was a lot of different like console logging and whatnot. It's just helpful to at least see what you are writing, what you are doing throughout all these different interactions. So here we're starting off and we're just logging some information about the network, the actual account that is deploying it. So this is my public key, 45. If you ever want to query and see how many tables I own a lot, because I do a lot of testing and it's kind of absurd, but besides the point. So we're going to be deploying the actual contract. That's really that first step. Before that happens, we're doing all of this like sort of groundwork with preparing the metadata, preparing these SQL statements. And as we saw in that script, it's basically just merging everything together. So that step we just looked at for inserting data into the tables. We're doing that right now. So we're writing the metadata to the actual tables. It's going to be basically passing those insert statements to an on-chain interaction with our actual Tableland registry smart contract. Talked about that at the very beginning, but so it's passing these insert statements, and this is actually what they look like. So insert into, here's the table that I just minted, the NFT main one. We have the data that I'm actually inserting into it. So that was all read from this metadata file here. And then recall that we had used that metadata processing to actually upload information to nft.storage. So this is the image itself and what nft.storage basically spit back after it pinned the file and uploaded the file to IPFS. So we have our first NFT main, and then we're also inserting the values for the NFT attributes. So again, both of those are part of the script itself. And as noted, if you want to get efficient, probably better to handle things a little bit differently. I'm basically passing a single statement at a time, but you can have multiple statements together in a single smart contract call. There's a limit on how many you can actually pass the smart contract, just based on limitations with blockchains in general. You have to have a limit in terms of just like gas. So because it wasn't really an issue with this tutorial, didn't really go through that detail. But as these things get going, you'll see some additional information that I thought would be helpful just to maybe show in the actual script, but probably better suited for a testing scenario. And you'll notice down at the bottom, like what I'm going to do after the data is written to these tables is just mint an NFT in real time and just include that as part of the script. But yeah, maybe not always necessary. You probably shouldn't just automatically mint a table when you deploy an NFT collection, but it's cool things to do with ethers and hard hat, etc. And basically, so down at the bottom, what's going to happen is we'll see like some links to these end outputs. So we have like the contract. We can view that over on mumbai.polygonscan.com. So we can see exactly what that looks like. Down here at the bottom, we actually have a verification script built in here. So you might want to do this separately. Again, wanting to merge everything together just to make it sort of a seamless experience for the sake of the demonstration. But we're going to even verify the contract, and then we can interact and mint tables if we want. And if we have time as well, we can do that. So you'll see, okay, boom, we read just some of the logs. We deployed the table. Here are the transaction hashes for the creation of, well, we've deployed the contract. We have some transaction hashes for the different tables that are created. We inserted the data here. We can see that this was that base URI, just sort of making it pretty explicit in terms of how that NFT data is rendered. And then we also have like the token URI for that token that I just minted there. So you can see NFT minted token ID, minted to me. The token URI is going to look something like this, which should be familiar. It's exactly what we looked at the beginning. Scroll back over, verifying contract. Okay, we verified the contract, and it's all available on Mumbai, Polygon Scan, Mumbai. So here's our contract that we just minted a minute ago. And then that first interaction was actually minting the NFT itself. So all this is verified through that script. You can read some of the data. So just to hit the point, basically token URI, we just minted 0. If we query it, that brings us to this token URI that we were just looking at. And that is essentially what we see here. So that sort of merges everything together. So just a quick recap. We did a lot, we walked through a lot, just enough time, a few minutes left here today. But we deployed an NFT using Tableland, Polygon, and NFT.storage. We wrote a smart contract. We parsed some files locally in order to make that happen. And then we used Tableland to deploy a couple of tables. That made it all straightforward in terms of merging this data together. So if you have any questions, feel free to hop in our Discord. Tableland Network over on Twitter. You can find our Discord link there. I'm Dan Buchholz, GTB if you hop in our Discord, or GT Buchholz on Twitter if you have questions as well. And so from there, I'll hand it back over to you guys.
Excellent. Thank you so much, Dan. There's really great workshop on, just making our NFT deployments so much more robust. Definitely useful if you're building a game, as I know some people are, and you're deploying that big collection of NFTs to fill your game inventory. So I encourage everybody who's watching to look into this as a solution in this hackathon even. Dan, thank you again. I am going to invite everybody over to gather.town. There's a link in the description right now in about 15 minutes. So we'll take about a 15-minute intermission and then meet up over there just for a casual discussion. If anybody has questions, feel free to bring those questions or comments, or even just come and talk about what you're building. We're happy to hear about that too. Dan, if you have some time, I'd like to encourage you to join us. I can give you that link here as soon as we go off the air.
Sounds good. I'll be there.
All right, perfect. Well, we'll see everybody in a little bit.